welcome all. Good morning. This is day 6, session 11, and we have our speaker, Dr. Sanjay Kumar Panda. He's an IEEE senior member and CSI and ACM distinguished speaker. He is going to deliver a talk on blockchain, fundamental types, and consensus mechanism. Let me introduce Dr. Sanjay. Dr. Sanjay Kumar Panda is working as an assistant professor in the Department of CSE at NIT Warangal, Telangana. He worked as an assistant professor and head of department CSE at IIIT DM Kurnool, Andhra Pradesh, and also as an assistant professor in the Department of IT at VSSUT Burla, Odisha. He received PhD degree from IIT ISM Dhanbad, Jharkhand, MTech degree from NIT Rourkela, Odisha, and BTech degree from VSSUT Burla in CSE. He has 9 years of teaching and research experience, received 22 awards from IEEE, IEI, ISTE, CSI, and others, which includes 2 silver medals from awards for the best graduate and best postgraduate in member and is listed in the top 2% of world cities in a single year impact as per the survey conducted by Stanford University, USA and Elsevier in October 2022. He has published 120 plus papers in reputed journals and conferences and edited 4 books. He is a member of IEEE, IEI, life member of ISTE, and life member of CSI. His current research interests include cloud and fog computing, artificial intelligence, machine learning, and Internet of Things. He delivered 150 plus invited talks and chaired sessions in many national and international conferences. He has guided 30 BTech students, 17 MTech and MPhilosophy and MCA scholars, and 2 PhD scholars, and guiding 5 PhD scholars. His Google Scholar citation reached 1750 plus and with an H index 23 and I-10 index 44. He acted as a reviewer in many reputed journals of IEEE, ACM, Elsevier, Springer, and Hindawi, and many reputed conferences. He also served as a guest editor in many international journals. So it's our honor, sir, you are here with us, and over to you.
Yeah, thank you very much, Dr. Gadbole, for introducing me. First of all, I would like to thank Professor P. Radhakrishnan and Dr. Sanjaya Gadbole to give me an opportunity to take 2 different sessions in this E&ICT online faculty development program on smart contract and blockchain technology. So a very good morning to all the participants. So my first lecture is on the introductory part of blockchain. It is for the beginner, those who have new to the blockchain technology. And in my second lecture, I will discuss about public and private blockchain in much more detail. And we will also do some coding, Python coding to understand the technology as per the time allotted to me. So we'll see some of the examples through which you will see overall highlight about this blockchain technology. So in the first lecture, I'll discuss about the basics related to blockchain and the concept of Bitcoin and how actually blockchain technology works. Then we'll discuss about the different types of blockchain based upon different, you can say, different characteristics, different features. It is categorized into different types. Then we'll go for the various consensus mechanism that blockchain has used to add a particular block into the blockchain. So in this 2-hour session, we are going to discuss about these topics which I have listed here. So you know about now all the technologies are heading towards Industry 5.0 or 5.0 from Industry 4.0. So first we'll see the difference between the Industry 1.0 to Industry 5.0, starting from, you can say, hydropower. Today we are talking about robot. So what are the invention happen in between 1.0 and 5.0, and the uh, future of the blockchain technology. Then we'll see the two important terms, that is what is the difference between the Bitcoin and blockchain, whether they are same or different. So with respect to different characteristics, we'll see how they are related to each other, and what is the basic difference between Bitcoin and blockchain. Then we'll see the evolution of blockchain. You know, the blockchain started in the year of 2008, and today we are in 2023. So you can see it is almost 15 years. So if you see, the evolution of blockchain is divided based upon the type of features it is providing. So it is now, you can say, it is divided into four different evaluation. Like we say Industry 1.0 to Industry 5.0. So here in blockchain also, in evolution, we say blockchain 1.0 to blockchain 4.0 or 4.0. Then we'll see some of the scenarios where we'll differentiate the traditional way of sending some amount to a person A to person B, and we'll see the online transactions, and we'll compare with if the transaction happens in the blockchain environment. Then we'll see how blockchain technology works, what are the components of the blockchain, what are the networking technologies behind the blockchain, and also we'll discuss about the advantages and disadvantages of blockchain, and some of the characteristics of blockchain. As you know that in blockchain, consensus mechanism is one of the popular mechanism, and blockchain is hosted by the peer-to-peer network. So in order to go for consensus mechanism, there are well-defined consensus mechanism available in distributed system. So one of these such type of consensus mechanism is called as PEX OS. It is quite old, but blockchain technology rely on this particular consensus mechanism. In fact, the consensus mechanism started from PEX OS. So after that, we will see different types of blockchain technology. We'll see public blockchain, private blockchain, permissionless blockchain, and permissioned blockchain, consortium blockchain, or federated blockchain, and hybrid blockchain. So based upon different the way we are deploying the blockchain, or the way we are working in the blockchain, so based upon that, they are categorized into different types. Then we'll discuss about the consensus mechanism, although other speakers also discussed about this thing like proof of work, proof of stake. But before going to the consensus mechanism, you should know what is Byzantine general problem. Once you understand the Byzantine general problem as a solution, we need some consensus mechanism. There actually that concept starts. So we'll see the objective behind the consensus protocol, why we need the consensus protocol, why it is important in the case of blockchain. Then we'll see the different consensus algorithm used in the blockchain. So these are the three things I will explain in today's lecture as for the time limit. And in between also I'll show you some of the demos or some of the websites where you can practice the basic related to the blockchain technology. Now coming to the fundamental part, first we will discuss about the industrial revolution starting from 1.0 to we are talking about now the 5.0 or 5.0. So if you go for industry 1.0, at that time there is no electricity. So people usually have get the power, or you can say electricity is generated from the hydropower, or machines are working with working by the help of water. In industry 1.0, again, if you talk about the manufacturing sector, industry 1.0, the production is very difficult. Later point of time, we can generate electricity from the water or stream power. So in comparison to industry 1.0, in industry 2.0, we have seen that the production is little bit increased. Now, with the invention of computer, and with the, you can say, development of information technology, uh, technology, IT technology, or you can say with the advancement of information technology, computers and automated productions, electronics equipment, these are used for increasing the production in the manufacturing industry. So we come with industry 3.0. Similarly, if you talk about industry 4.0, where we are talking about artificial intelligence, machine learning, Internet of Things, networking, these are equipped or these are used by different industries to increase the productions. And now in industry 5.0, we want application of such technology which we have seen in industry 4.0 to apply in the manufacturing industry to increase the productions. Like you can see human robot collaboration, cognitive system, customization, digital twin, digital thread. These all are now heading towards the industry 5.0. So in 2020 onwards, we have industry 5.0 that is applied in various industry. And with the advancement of Internet of Things and the popularization of, you can say, internet, now all are connected through internet. And if you see the statistics, 50% of the world is connected to the internet. Now you cannot imagine the world without the internet. And in order to make secure transaction, in order to make our life easier, we are using various technology in, you can say, in developing the products, designing the products in order to do a good application in a particular field. So we are using artificial intelligence, big data to deal with a large amount of data. Nowadays, we are talking about virtual reality, augmented reality. Like that, one of the very popular technology, that is blockchain. But alone blockchain cannot provide you the solution. Blockchain also require some integrated technology in order to provide you the solution. Like blockchain also required the for storage purpose, which is using cloud computing. It also rely on the internet. It also based upon the network communication protocol. All these technologies are integrated with the blockchain to provide a solutions to some of the problems. So as you know that a blockchain, where we are redefining how we can store, how we can update, and how we can move the data. We primarily focus on transparency, right? So nobody is going to alter anything in the blockchain. That's why earlier methodology, if you see, or earlier technology, if you see, where uh, you can say modification is very easier, or updation of the record is easier, right? But in this case, we rely on only append mode, right? We can append something, but we cannot alter the things. Now, if you come to the definition of blockchain, which is there is no standard definition. Many people define the blockchain in different way. So blockchain is defined as a distributed, replicated peer-to-peer network of databases. So as the name distributed means they are not placed in one location. Like if you see our internet distributed system, where we have different servers, but these servers are not placed in a single location. One of the advantages of this one is, in if a particular location is lack of electricity, or you can say in that particular location, if some natural calamity happens, so it is not going to impact the rest of the servers that are present in different part of the world. That's why distributed computing is, or distributed systems are much more popular for any real life type of application. So one of such application you can see blockchain, which rely on the distributed system. So here also you can see it is a replicated peer-to-peer network of databases. In peer-to-peer network means there is no master-slave relationship between different peers. If I consider two different peers, they are not dependent on each other. In order to make a particular goal, you require the assistance of both the systems, but they are not dependent on each other. Means whatever work the system A can do, system B also can capable to do that work. Alone also they can solve a particular problem. But when you go for the earlier architecture, like we talk about the client server architecture, there is a dependency between client and server, because client is you can say less powerful and server is more powerful. So client generally make a request to the server, and server provides accept that particular request and response to the client in order to fulfill the requirement. But such type of things is not there in the case of peer-to-peer network. And here we are saying replicated peer-to-peer network means whatever information available with the system A, the same thing is also available with the peer B. So in case of peer A fails, then you can get that information from peer B. But if you go for distributed computing, you can see sometimes if you talk about the trust, so one peer cannot trust another peer. Okay, anybody can participate in your network, but if you ask about the trust, one non-trust peer can also join in the network. So similarly, in the blockchain technology, we have no third party. Like normally, whenever we are making a transaction, we rely on bank, right? But here, there is no such party is required while you are making a transaction between one peer to another peer. So blockchain allows multiple non-trusting parties to transact without a trusted intermediary. So anybody can make a transaction without need of any third party, right? So when they are making transaction, so you can say they may be trusty, they may be trustless also, right? But how to integrate them, how to identify that one, how to ensure that they are not going to modify something into the network, that actually blockchain provides the solution to that particular thing. And obviously it is ever growing, it is append only, just you can add something into the blockchain but you cannot alter it. It is also called as a temper resistance list of time sequenced record. So all these technologies, if you see, the background is our peer-to-peer network, or you can say distributed network. But distributed network, we can modify something. Distributed network, you can update something. But such things are restricted in the case of blockchain. So it was first published in 2008 by Satoshi Nakamoto, but this name is not the original name of the you can say original name of that particular person. It is the pseudonym of a person, or after 15 years also we don't know who is this particular person. One of the interesting fact about the blockchain, that this person is not yet known to the community after 15 years of blockchain you can say evaluation. So he published a paper also with this name. His name is mentioned in that paper is Satoshi Nakamoto, but as I said, he is not the actual name of that particular person. He published this white paper. The name of that white paper is called as a peer-to-peer electronic transaction case system, electronic e-case system. So in this paper, he mentioned about the peer-to-peer network, and he also mentioned about how to make transactions. Okay, e-case means you deal with the physical case, right? Nowadays also we are using phone pay, we are using Google Pay, we are using Paytm, different UPIs we are using, where we are making a transaction that we can say it is a e-transactions or wallet transactions, right? So we are not dealing with the physical case. And the first application of the Bitcoin blockchain was Bitcoin in the year of 2009. The main problem which the blockchain can solve or Bitcoin can solve is that whenever you want to make a transaction, then you have to see that whether there is any third party available for you or not. Like recently, I want to send 140 euro to one of the account hosted by a Belgium person in order to register for a particular conference or workshop. So in order to transfer this 140 euro, I without any knowledge, I have started how we can transfer through online SBI.com. But unfortunately, although that option is available in the online SBI.com, but uh, after adding this beneficiary, I am not able to uh, transfer the amount to that concerned account. Then I visited SBI Bank, which is in our campus, NIT campus. I requested the manager to transfer 140 euro from my account. So in order to transfer this 140 euro, they asked me to submit a PAN card. They also asked me to submit Aadhaar card, a written application, proof who has sent me to send, who has told me that to send this much amount to them. And also they have asked about some applications which is the mandatory requirement for bank to fill up that one. So what you can see here, in order to transfer something outside the boundary, means outside our country boundary, we need a lot of things to fill up. Okay, lot of things to provide in order to make the transactions. Imagine this is not a urgent situation, but if there is a urgent situation happen where you want to transfer some money urgently within, you need that amount need to be reached to your destination or the receiver within 10 minutes. So it is not possible if you want to do through our trusted bank network, right? So again, after submitting this application, I have seen that after 8 hours, the amount is credited, means it is debited from my account. So I feel that it may be credited to the receiver account maybe in another 1 hour. So what I tries to convince you that there is a cross-border payment is very, very difficult in our current network. Although we are not, as a user, we are not using any blockchain network, but if you see our online SBI, which we trust a lot, any bank you are using, we trust that particular bank. But making a payment is such a difficult process you have to go through in order to make a transaction from our country to any other country. So that cross-border payment is much more easier by the help of the blockchain. Now here you can see blockchain was coined in the year of 2008. Bitcoin was coined in the year of 2009. So as a new beginner in this particular field, you may wonder that what is the difference between this Bitcoin and blockchain? Or can I use these words alternatively? So let us see in this slide. So Bitcoin is a cryptocurrency. Not only Bitcoin, after Bitcoin also, people have come up with a different cryptocurrency, like pure coin is there, other things are there, right? But blockchain is a ledger or a database of information. Like if you go to your account department, then you will see they maintain everything in the form of ledger. You see our bank passbook, there also we have debit information, we have credit information. So everything is maintained in the form of a ledger, right? So like blockchain also, it is a ledger, but as it is applied in distributed system, okay, we can say this ledger is available in each and every node that are connected to the distributed system or peer-to-peer network. So blockchain maintains all transactions of the Bitcoin. If you want to transfer Bitcoin or if you want to purchase a Bitcoin, everything is maintained in the blockchain. So you can say blockchain acts as a Bitcoin's ledger. It maintains all the transactions which you want to make in the blockchain network. It is maintained in the ledger. And Bitcoin case, it has a high degree of anonymity. That means it is very difficult to identify the user. Identity of the user is not revealed. Like I mentioned, that Satoshi Nakamoto, so his identity is not revealed till date after 15 years also. And blockchain is quite transparent because the same information is available with multiple nodes. So it is completely transparent because if you modify something, it is not impacting others. Rather than they can identify that you have modified it or you have made a particular request to modify. Now, if you can see about this Bitcoin, Satoshi Nakamoto has roughly 1 million Bitcoin, which we represent as BTC, Bitcoin, worth around $8 billion as of 2019. And this price is increasing, or number of Bitcoins are increasing day by day. Now coming to the evolution and generation of blockchain, like we discussed about Industry 1.0 to Industry 5.0. Similarly, blockchain is also having four different generations. Starting from 2008 to today, we have 2023. So the origin of blockchain is the first version of blockchain, which we call as blockchain 1.0. It is from 2008 to 2013. Blockchain 2.0 is related to Ethereum and smart contract, which is also one of the uh, important topic of this particular faculty development program in between 2013 to 2015. Blockchain 3.0 talks about a distributed application, that is 15 to 18. Now we are in Blockchain 4.0, that is 2018 to future, where we focuses on how faster we can do transactions. Because the transaction in the case of blockchain is quite slower in comparison to normal transactions what we make in our day-to-day life. So maybe upcoming future, we may get the transaction time is as low as possible. Like now we are making a transaction, which is very takes very less time if it is within the boundary. Although it takes more time when you go outside the country or you are making transaction to the outside country people. But in general, the time is now less. But in the blockchain network, it is more. So maybe in future it may be also whether it's a inside transaction, inside the boundary transaction or outside the boundary transaction, Bitcoin takes the same time, right? But when you go for our current system where it varies with respect to in which country you want to transfer, where you want to transfer, based upon that the time varies. So in 12 January 2019, the first successful Bitcoin transaction happens in the blockchain using the blockchain network. So this transaction happens between Satoshi Nakamoto and Hal Finney. The first transaction identified in 12 January 2009. So they have used a particular protocol which is a very famous consensus mechanism which is called as a proof of work for this particular transaction. Right, I'll tell you about this proof of work while we'll discuss about the different consensus mechanism. But you can see Bitcoin is one of the slowest cryptocurrency because it requires 10 minutes to confirm a particular transactions. Like I mentioned, if you go for if you want to transfer some amount from India to Belgium and other country, it takes 8 hours, right? I mentioned that example, it takes 8 hours. But if you want to make a transaction within our country, you want to send some money to your friend, so it requires fraction of second to transfer the amount. But in the case of Bitcoin, you can see whether it is within the country or outside the country. In average, you can see it requires 10 minutes time to confirm a particular transactions. So with respect to different evolution and generation of the blockchain, you can see that the processing time is going to be reduced, right? Earlier it is more, but now people focus on how to make this transaction faster. Coming to blockchain 2.0 in 2013, Ethereum was started. So the main purpose of this one is to B2C network, that is business to consumer network, right? So Bitcoin could be used for all kind of B2C and other general applications. So not only how to make it use in a business network, because ultimately you have to apply in the business network. Our bank network is also target towards the business network, right? So here also they have used the same protocol for consensus mechanism, that is called as proof of work algorithm, but it is less than the optimal speed which they have identified, and Ethereum required very less energy to maintain in comparison to the previous one. But there are also some issues related to the Ethereum, that is related to the scalability. When the number of users increases, when the number of transaction increases, so how to maintain that, that is also more challenging. In order to avoid that, we have smart contract as a solutions to this scalability problem. Coming to next generation, that is blockchain 3.0. Like if you see applications, we have a lot of application in our mobile. Through our internet service provider, we are getting internet service, or you are downloading any application through your internet service provider, and these ISPs are connected to the data center, right? Like Amazon is having data center, Google is having data center. Services are provided from the data center through your internet service provider. This way the application works. But in blockchain 3.0, they come up with the D apps, where you can see there are multiple ISPs, and the ISPs can also communicate with each other, right? And you can see our mobile or our devices are connected to the internet service provider. One ISP may be connected to another ISP to provide the services. Like sometimes also we encountered when we go for a particular location where your preferred network is not available, then it is tie up with another internet service provider. So although you are using X provider, but as X provider, look, X provider network is not available in that particular location, you will get the service from the Y provider, because there is a tie-up between X and Y provider. So in blockchain 3.0, the arrival of Hyperledger from the Linux Foundation and decentralized applications, which we call it the DApps of Ethereum. And smart contracts of Ethereum opened up the possibility of proof of stake consensus mechanism. So previously we used proof of work, that is POW, but now we come up with another consensus mechanism that is called as proof of stake. Again, proof of work and proof of stake, they have their own advantages and disadvantages. I'll tell you in detail whenever we will go for the consensus algorithms or mechanisms. Next is EOS and TR1 have taken over this DFs market, that is decentralized application market, due to scaling issues. So obviously scaling is a issue in each and every sector, right? If the number of transactions uses, number of users increases, how to handle that one? Like many, if you talk about social networking website, if you talk about online shopping websites, day by day the number of users are increasing, right? Number of requests are increasing. So you have to see that without increasing the infrastructure, how you can manage them, right? If at all required, you have to extend the infrastructure in order to deal with that, right? So that's why scaling is always a issue for all type of technology. Like here also you can see both US and TNs have taken the market of DApps due to this particular issue. Coming to the latest one, that is blockchain 4.0, where we are talking about scaling factor. where we are talking about how to reduce the time, transaction time, how to increase the speed. Okay, and overally, irrespective of the things, first we have to see that we are not compromising with the security. Security is the primary concern, right? If security is violated, even if you are providing a lot of features, nobody is going to accept it, right? Like computation is more important, but at the same time, you have to see when you are doing any computation or you are making a communication, security is not violated. It may be a lightweight security mechanism, but it is not going to be violated. That you need to be assured to your provider. Now, let us see the difference between the traditional way of transaction and the blockchain-based transactions. So we'll see three different type of scenario through which you will see what is the basic difference between the traditional transaction and the blockchain-based transaction. So here I have taken two user, one is Joy, another is An. So actually Joy wants to purchase a painting from Anne. So he visited the store of N and hand over a physical $50 note to N, and N has provided the painting to the Joy. So in this case, you can see $50 is with Joy. Joy hand over the $50 to N, right? So the amount with N is increased by $50, and the amount with Joy is reduced to minus $50. Okay, and you can see the painting is handed over to the Joy. So it is completely a physical transaction which we do long back, not now, right? Nowadays we are very much habituated with online shopping, but earlier traditional way we are doing this one. So you have to visit to a particular store and you have to purchase a particular thing, you have to pay it, and after that payment, then you can take that particular thing from that particular store. But coming to another scenario which we are using nowadays, suppose both party Joy and Anne, so they cannot meet each other. Okay, they are very far away or they are busy in their work, they don't want to meet each other, and they want that this transaction happens, need to be happen between these two parties. So they decided to make a transaction online, right? That's why they rely on a third party. One third party may be like we are using phone pay, we are using Paytm, we are using Google Pay, which is providing us UPI, right? And you can see that these things are also more or less related to the bank, right? Through our bank account only, we are going to provide, we are going to get these UPI IDs. So there is a central authority or intermediary between the Joy and N, which is our bank. And bank actually maintains a centralized database and ledger. And these ledger is updated in each and every second, right? Suppose you have paid some amount to someone, then you can see your bank balance automatically. You can see the bank balance is updated. Okay, so the ledger is maintained that very frequently you can update the ledger, and the same thing will be available to the user. So bank is considered as a trusted third party between the Joy and N. In some cases also bank charges some amount for a particular transactions. Like if you talk about SBI, then I can say that if you want to go for interbank transfer, you are paying some amount. Right, within bank, it is limited. It is free for some amount or some number of transactions. But if you go beyond that, again you have to pay for some transaction charge. So you can see the Joy has make a transaction of $50. So he has sent 50 and 50 is deducted from Joy's account, and bank has received that amount, and bank transferred that amount to Anne's account, right? And once the transaction is successful, bank deduct $1 from Joy's account and deposited to its own account, right? Or the account maintained by the trusted party added to account. Nowadays also when you make a recharge in phone pay, they are asking for transaction charge, right? This is the way we are making the online transactions. So you can see transaction charge is also more, like I transferred 140 euro to Belgium, but I have observed that 25 euro deducted, right? I transacted only 140 euro, but 25 euro is deducted as a part of transaction charge by SBI, right? So amount is very high. The transaction charge is very high if you go for a cross-border payment, but through blockchain you can avoid it. So coming to this example also, you can see, yes, as I told, bank debits Joy's account by $50 and add $50 to Anne's account. And once Anne verify that her account is credited, she sends Joy the painting. Right? Your receiver has to verify the payment. Like we are purchasing something from Flipkart and Amazon. Once we have placed the order, okay, they have checked the payment status. Their payment or account department confirms the payment. Then your item is shipped to uh, your address, right? But in the real life scenario, as I said, exchange charges are there, transaction charges are there. Sometimes you have to make a transaction between two different banks and two different banks that are not residing in the same country. So in that case, it is very, very challenging for you to make a transaction. Now coming to the blockchain transaction in scenario number 3, here both party, sender and receiver, the Joy and Anne, both are members of our blockchain network. They participated in a blockchain network. So Joy has initiated the transaction of $50, okay, worth of a Bitcoin or cryptocurrency, right? So this request is reached to the blockchain network, and it is going to be verified by or validated by the blockchain network, and N receives the $50 equivalent in crypto. The same 50 amount which you want to transfer from a sender to receiver, receiver has received that in the form of crypto. And there is no intermediary fee, there is no, you can say, trusted third party in between the sender and receiver. So in between the sender and receiver, what we have? We have a blockchain network. And once N receives and verify and seen that that amount is credited, like the online transaction, she sends the painting to the Joy. So here everything is maintained in the blockchain network, and N can verify whether Joy has sent that amount or not. And similarly, Joy can also see whether N has received that amount or not. Right? That is type of a transparency the blockchain network is going to provide you. Now talking about the various blockchain concept, so you need to see the difference between the client server network versus the peer-to-peer network. If you see the first figure, these all are called as a client. I can say C1, C2, C3, C4, C5. These are the different clients. Generally, clients are called as a thin client because they have limited power, and you can say server is called as a thick server because they have more power. So multiple client make a request to the server, and if the server can provide that resources, then server responds to the client by providing that resources. Okay, so earlier, in order to transfer the file transfer protocol, or in order to transfer file from one client to another client, you require the help of the server, right? For example, C1 wants to transfer the file to C2. C1 will make a request to the server, and server will redirect that to the C2, right? So communication, whether you want to receive some kind of communication, you want to send something, each and everything you require the intervention of the server. Without server, you cannot transfer or cannot receive a particular file. But problem with this system, is that if there is a single point of failure, if the server is failed, then you can say the entire network is out of order, or you can say the entire network is collapsed. That is the drawbacks of our client server network. So when you go for peer-to-peer network, you can see here one peer is connected to another peer with a dedicated network, right? Or dedicated lines, you can say. So every participating node in this particular network, they could request and serve the content. Like this particular peer P1 can make a request to peer 2, right? And this request is made between P1 to P2, but the content is delivered from P2 to P1. At the same time, if P2 needs something which is there in P3, then P2 can make a request to P3, and as a content, the content will be delivered from P3 to the P2. So all these peers are connected to each other to solve a to solve a particular goal. So if there is a failure happens to a particular peer, it is not going to hamper the whole network. Obviously, computation is going to hamper little bit. Sometimes there may be a instability in the network due to the failure of a particular peer, but it is not like the client server network. Like if there is an update which is need to communicate from P3 to all other peer, but P3 collapsed or failed, then that update will never reach to other peers, which makes instability in the network. But it is not like the client server network, right? The entire network is not going to fail. Or due to, or you can say by developing a new kind of mechanism, you can solve these problems. So you can avoid the single point of failure in the case of peer-to-peer network. However, if the number of peers are less, right, which we call as a smaller blockchain, the number of nodes are less, number of blocks are less, then it is prone to attack. But if the blockchain is very large, okay, it consists of number of blocks, then the probability of attack is very, very less. So in peer-to-peer network, it may happen that a single peer node can influence other peer node, or a group of peers together with the same interest as they have majority in the network. Suppose there are 10 peers are there, 6 peers, they have make a team with a common interest. So they can launch a particular attack, or they can support a particular attack. So which we referred in the blockchain network as a 51% attack. So if you can to make a 51% of the people or in the node together, or you can take a decision of this particular node, then you can alter a particular network, right? But it is very rare because the number of nodes or number of peers are very, very large in the peer-to-peer network. Now, we have another important concept in the blockchain network that is related to the public key or asymmetric cryptography. So if you go for cryptography, there are two different type of cryptography. We have symmetric cryptography, we have asymmetric cryptography. In symmetric cryptography, we have a key that is shared between both parties, sender and receiver. Like two friends are sharing a room, right? And they have two keys of the same room. So if one person unlock, then another person can lock. Okay. Or if a one person is locked that particular room and he visited somewhere, then another person can come and unlock it, right? So the same key is given to both the parties. But when you go for asymmetric cryptography, we have a pair of key that is called as public key, another is called as private key. And this public key and private keys are used for encryption as well as decryption. In fact, this cryptography mechanism was not new, it is quite old. It was proposed by two Stanford mathematicians. One is Whitefield Diffie and Martin Hellman, which we call as Diffie-Hellman algorithm in 1976. That is asymmetric cryptography because we are using two key. One is public key, another is called as private key. Like you can see our email system. In our email system, we have username, we have password. You can say username is considered as a public key, but password is your private key. Anybody can send an email to you, but you are the only person who can see that particular email. So that is also an example of your asymmetric cryptography. But one of the interesting fact you can see here, a public key cannot decrypt the message encrypted by public key. Okay, public key means your username, right? A username cannot be used to decrypt a particular message which is encrypted by public key of another person, right? You have to use the reverse one. Public case you can use private, private case you can use public, but not the same thing. Similarly, private key cannot be decrypt the message encrypted by a private key. That's why we say that in asymmetric cryptography there is a pair of public key and private key. I'll show you the code also in later part of this talk, where you can see how to generate such key by writing a very simple code in the Python environment. Now there is another important component in the blockchain, that how actually this network works. We say non-trusted party, right? We don't know there is third party whether it is a trusted party or not. So while we are talk about trust and reputation, trust, you can trust a particular person, you cannot trust also a particular person. Somebody influenced you with some comment, and you have say, let's say, accepted that comment, then your trust, you can say that person is not good, right? So trust is purely a personal opinion. Today you may trust someone, tomorrow you may not trust someone, right? So that is purely a personal opinion. But if you look into the reputation, reputation is not personal. Reputation is based upon the public opinion. Like if you see a e-commerce site, if I ask you, I want to purchase a particular product, which site I am going to purchase the product? Then you will say, no, this particular site is providing the product with a better price, better quality, and something like that. So it is a public opinion, but it is not a personal opinion. So here, we trust relates to two different questions. First question says that, are you whom you say you are? In order to address this question, you have to see the identity, or we call it a authentication. Authentication can be done by using a username and password, or you can say public key and a private key. Second question related to trust says that, do you have the right? Suppose some transaction you want to make, but do you have that particular right to do what you want to do? That require permission, which we call as authorization. So in general, whenever a higher authority of a particular organization is out of station, then he delegate that power to another person who is senior, who is next to him. So what actually doing? That person has given temporary role to give access right. Okay, to have the access right to make a particular transactions. So that is called as a permission. Like we have seen also in the bank network, whenever you want to make a big transaction, whether deposit or withdrawal, so it is initiated by one person, it is approved by another person who is sitting next to him. Why? Because that require one more round, right? Just like a two-step verification, here also we are doing that kind of verifications. So that permission, whoever is initiated it, whoever is going to approve it, both need to be the different person. They should not be the same person. So different rights, different permissions are given to different people. So in this network, blockchain network, you can see, as I said, public and private keys are generated and stored in a place which we refer as a wallet. Like you can see here, Joy has its a private key as well as the public key. Like N is also another user, So C has also one private key, one public key. And in order to make a transaction, suppose Joy wants to transfer 0.5 BTC, that is Bitcoin, to N. So what he need? First he has to N shares her public key with Joy. Suppose you want to send me an email. First you have to know my email ID. So N is your receiver, right? This is your sender. And this one is your receiver. So in order to send any message, you need receiver's public key. Okay. Once you get the public key, then what Joy will do? Joy sends the request to transfer a particular amount. Like here I have considered that amount at 0.5 BTC from his wallet to N along with the N's public key. You can send me an email by typing my username. Okay. You can give the details about, you can write the body part of the email. You can specify something, but you need my public key. So you need the public key of the receiver in order to make a particular transactions. Now you can see this 0.5 BTC with this public key of N, it is encrypted, right? And which we represent in the form of a ciphertext. Plain text is converted to ciphertext, which we call as encryption. Ciphertext to plain text, which we call as decryption. Then we send that through a blockchain network. Once it is received to N is going to verify that particular transactions, and C receives the encrypted message and decrypt it, right? How he will decrypt? How she will decrypt? Using her private key, right? How you can read your email? Suppose I have sent an email to you. You can read that email using your private key. So Anne uses her private key and receives this 0.5 BTC in her wallet. So whether it is a blockchain network or a bank network, we do the transaction in like that only. In order to transfer some amount, you need account details. You need account number. You need, let's say, IFC code and bank name and other things, and that account holder name. Then you can transfer. But how your receiver can check whether you have successfully sent or not? By checking his account with the private key. That is, you can say password, or by using the profile password, you can check, right? Now, what is the guarantee here? How can we guarantee the authenticity of the data and ensure that it will not be tampered within transit? So encryption decryption mechanism is not new. Like I mentioned in 1976, this technology started, asymmetric cryptography. Long back, right? It is around, you can say 50 years, closely 50 years. So in between, people can get this encrypted message. If they have key, then definitely they are going to decrypt it, right? Or if somehow they have got the key, or they have some hint to get the key, then the encrypted message can be decrypted. So in order to make it a tamper free in the blockchain network, we use digital signature. And this concept of a digital signature having three different parts. First one is generation of the private key and public key. I told you there is a pair, public key, private key. You can convert by generating a particular key, you can convert to another key. You can write a simple code in the Python to convert it. I'll show you that code. The second step is the signing algorithm. So signing algorithm will help you. Suppose sender wants to send, sender has to sign that yes, this particular thing belongs to him, right? And there is a verification algorithm to check that whether the same thing is reflected in both the user's account or not. So coming to the verification algorithm here, how to verify a particular transaction in the blockchain network. So you know Joy and N, they share their public key with each other. Public key is known to everyone. Otherwise, they are going to share also, because it is for public users only, right? Anybody can get this information. Then why? Then what Joy did here? Joy generates a hash. So the hash is like this. It is a just like a, you can say it is a 256 bit. If you go for SHA 256, we are generally using SHA 256 in the case of blockchain, right? So you can say there are 64 characters, hex letters, right? So you know hexadecimal means 0 to 9 and A to E. So total, okay. Total you have 16 character, right? 10 plus 6, A, B, C, D, E, F, right? So total is the six total hex 16 different you can say alphanumeric characters are there, right? So through that you can see Joy can create a particular hash, and irrespective of the message size, whether the message size is you can say the a paragraph or the message size is same as a dictionary, the hash size is same only. It is only 64 hex digit or 256 bit. So in the transaction file, you can see the information related to 2n from Joy. This is some unique number. The amount is 0.5 BTC. This amount is transferred for painting purpose on a particular date. So Joy generates a hash of this particular transaction, and using his private key is encrypt the hash, thus creating his digital signature. So you can see this is our transaction file which we have converted to a hash. This hash consists of your 64 hex digit by the help of a hash algorithm. The hash algorithm we have used, that is SHA 256. Then N uses its private key to get the its digital signature, creating his digital signature. Then Joy again encrypt the digitally signed transaction file. This transaction file is digitally signed and uses N's public key and send it to N via the blockchain network. So here you have converted to the hash. You have the key, right? That is your private key. You generated the digital signature. The digital signature is associated with the transaction file, and using the receiver's public key, you have made the encryption, which is converted into the ciphertext. Then you have sent to the blockchain network. And when N receives it, the encrypted transaction file. So he got this encrypted transaction file. She can decrypt the file using her private key to access the Joy's digitally signed document. You can see and receive the ciphertext here, right? After that, she separated, okay, using her private key. So he has generated this Joyce digital signature, access to this Joyce digital signature document. Okay, then it comes with verification algorithm. This is not the verification. I mistakenly written here verification algorithm. This is nothing but the signing algorithm, right? Which is the second step. First step is to generate this private key and public key. Second step is to go for the signing algorithm. Third step is to go for the verification algorithm. So N receive this particular message, that is transaction file as well as Joy's digital signature. So C can generate the digest, which we call as message digest also, by running the hash algorithm. So one part is completed, right? This hash is generated by using the transaction file and hash algorithm. Okay, the digest will be used for comparison. So what for the comparison, what it will do? It will take Joy's digital signature, okay, and decrypts the Joy's digital signature and using his public key to get the message hash. So there are two ways to generate the hash. One is transaction file plus hash algorithm. Second one is Joy's digital signature with the public key of Joy, right? Then these two hashes are compared. So with this hash value, as it is unidirectional, one-way function, you cannot get the transaction file, right? So we have compared these two hash, and if there is a match, right, then we can say this file is actually originated from the Joy. Okay, this is an authenticated transaction file. So after comparison of these two hashes and confirm the transaction is from the sender, that is Joy, and she has dispatched the painting. Okay, and also seen that there is nothing tempered in between. If there is a if there is any change in between in any network, then you will not get the same hash value. That's why digital signature are what gives the recorded data recorded on a blockchain its immutability. We say blockchain is immutable because by the help of digital signature you are doing this one. So if there is any kind of modification, that we can easily get it. So authentication, which we said about identity. So I asked one question related to the trust. Are you whom you say you are? So that is addressed by the authentication, and authentication is done by the help of digital signature. Coming to authorization, authorization means you are giving permission, or it is related to the trust question, that do you have the right to do what you want to do, right? So that is done by distributed consensus on a peer-to-peer network of blockchain. Consensus will give you whether it is a correct thing or not. Like I mentioned that whenever a higher authority is out of station for a particular organization, he circulates a message, he or she circulates a message that he or she was out of, she is going to be out of station for these many days, and in place of him or her, another person is in charge of his office, right? So that is a consensus, right? After getting this letter, all the employee of that particular organization is aware of that, that which making a consensus mechanism. Similarly, in the peer-to-peer network, we did the same type of consensus mechanism, which will help to satisfy the properties of authorization or permission. Okay. Now, if you coming to the another component, right? One of the important component of the blockchain is node. So node may be anything, right? It may be a computer, it may be a mobile device, it may be a server, it may be a hardware. Starting from a lightweight device to it may be any device of any power. So in blockchain network, each and every devices is having a copy of the blockchain ledger. The ledger is not kept by the trusted party like bank. Rather than the copy is available in each and every node. But when you see a particular node, then you can say if I am having a device, okay, which is less computation power or less processing power, it is a lightweight device. It cannot store a large amount of transactions. So can I participate in a blockchain network? The answer is yes. That's why the node is divided into two parts. One is called as full node, or another node is called as partial node. You can say lightweight node or light node. So full node means you have entire transaction history with you because you have uh, storage power, you have processing power. That's why you are able to keep a large amount of data. But if you have less processing power, okay, you don't have sufficient disk space. Your node is do not have any sufficient disk space. In that case, you can consider the partial copy of the ledger. Like somebody will say that I can keep the transaction up to 1 day. I cannot keep the transaction of last 1 month. So that can be considered as a lightweight node. And these lightweight nodes, what they are doing, they download only the block header to validate the authenticity. If you go for the entire message, it may be very huge, right? But if you take only the header part, whenever we are making the transaction also, right, in a particular network, if you transfer a particular packet, each and every packet is having a header. With the header information, you can determine whether it is intended for that particular node or it need to be forwarded to other node, right? Sometimes we receive a message as an intermediate node. By looking into header, you can determine, no, this is not belongs to me. I need to forward it to the next node, neighbor node. Similarly, here only block header is used to check the authenticity. And this method is popularly known as simplified payment verification or called as SPV. So when you have less computation power, less disk storage, okay, in that case, only you need to concentrate on the header part. Okay, and the payment can be verified through this SPP method. Coming to another component of the blockchain, that is called as ledger. Like I mentioned, each and every node in the blockchain contain the ledger, right? There may be some part of the ledger or maybe the complete transaction history, right? So the ledger may be public. Public means anybody can join in the network, can download a copy of the ledger. Or the ledger is distributed. Distributed means each and every peer got one copy of that particular ledger, which is contain the duplication. You can say the same thing is appeared in multiple places, which we call as a replica. Replica of this ledger is available in each and every node. That's why we call that as a distributed. And ledger is decentralized. Decentralized and distributed don't they are related to each other, but there is a difference. Distributed means not located in a particular place. Decentralized says that one node should not keep everything. Right? If a node is having all the things, then that node may get failure. Right? If the node is failed, then the entire network is collapsed. That's why ledger is decentralized to avoid from single point of failure. Distributed says that everyone is having the same copy. But decentralized case, maybe in a distributed network, you have n nodes, but only few nodes, or you can say you have identified some nodes. Those nodes are having only the copy, but rest nodes, they are only the member of that particular network, but they don't have the copy. That may happen, right? Like if you go for different consensus mechanism, you will see the power of each and every node. And we also say it is a distributed database, right? Database means it should be consistent. In order to retrieve something from the database, it need to be updated frequently. So when you say distributed database, if it is residing in multiple places, then you have to ensure that they are having proper consistency. There should not be any kind of inconsistency in the network. Like if you go for traditional database, we can create, we can read, we can update, we can delete. We call this as a CUID, right? But if you go for blockchain, creating a block is possible. You can read a particular block, but updating delete is not possible. That's why we call that as a append only mode, right? You can add something into the blockchain. You cannot modify what is there in that particular network. Another interesting part in the blockchain component that is called as wallet. Actually, our UPI apps, okay, also having the wallet. The wallet actually manages the cryptocurrency. Like person A wants to send some cryptocurrency or coins to person B's wallet. So actually it needs to be transferred from person A's wallet to person B's wallet. So suppose I want to transfer, let's say $10. Okay. Then if person A wants to send $10 to person B, right? Then after transferring, initiating this one, it has to signing of the ownership of these coins. Once you initiate a particular transaction, you cannot claim that these coins again belongs to me. And person B can spend the coins. Once after receiving this $10, person B can spend. But before that, it will check the private key stored in person B's wallet. Is it matching with the public address of the cryptocurrency? We have to compare person B's private key, which is stored in his wallet, in his or her wallet, right, with the public address the cryptocurrency is assigned. If there is a match, then person B's wallet is increased and person A's wallet is decreased, right? So we can say it is a successful transactions. So it is based upon the private key stored in person B's wallet. Like we are making a transaction, we are transferring some amount through this API here. Once its validation is done like this, then the amount is credited to the receiver account and the amount is debited from the sender account. And this transaction happens in fraction of second. That's why we have not known about this thing, right? And in fact, if you go for how actually it is done based upon this particular method, actually it performs like this. So privacy is maintained, right? So this private key which is stored in person B's wallet, it is not known to person A. So we have maintained the privacy, and transaction is also very secure, right? Until unless if there is any modification, then definitely we can identify while we are matching, and it is very easy to use, and there is no need of any currency conversion, right? I have purchased the cryptocurrency, right? Or I have sent that cryptocurrency coins to my receiver. So I need not worry about whether it is in dollar or it is in, let's say, in rupees or it may be in euro. So there is no need of this when we make a cross-boundary payment. Another important component in the blockchain that is called as nonce. So nonce is nothing but a number which is generated randomly. Like we generate a random between, suppose I'll tell you to generate a number between 1 to 100. Then somebody will say 90, somebody will say 80, somebody will say 70. So different period of time you will get a different number. Okay. Similarly, we have another component that is called as hash. I already mentioned it is of fixed size. Like you write a single word, or you write a single letter, or you put a space, or you write a as big as a dictionary, you will get the fixed size of hash. And you can generate the hash, but it is not reversible. Once you can generate the hash, if I give you the hash and I'll ask you that find out what is the text, input text, it is not possible. So blockchain hashes are 256 bit and 64 alphanumeric bit. That's why I said it is 0 to 9 and A to F. Okay. Earlier I mentioned E, sorry. It is 6 and this is 10, right? Total 16. So 256 bit and 64 alphanumeric character. So you can say one alphanumeric character is equal to 4 bit. So 64 into 4, it is 256 bit. So we use secure hash algorithm, that is SSA 256, as a part of blockchain. Okay, you can visit this particular link. I'll share in the chat box. You can visit this particular link where you can get how to generate the hash values. So let me share this one with you. Just a minute. So irrespective of the text, you will get a 256 bit info hash, or you can say 60 bit. So you can go to this website which I have said in the chat box, and also I'll share another website with you. Okay, we'll show that one. I'll show the slide. Then you can type in this particular. Yeah. So now see here, I have shared this link with you. You go to that link. This is a SHA 256 online tool. So here you can provide your input and you will get the hash value as an output. For example, you can see I am putting a space. I am getting a hash value of 64 hash digit. Or I'll write OK. If I write OK, then you are getting 5653 point something. You can go to slide. You can see if your input is OK, you are getting the hash result is 5653 followed by the rest of the hex digit, right? Now, if you write the world, for example, I have written a sentence here. The world is a balloon. The world is a balloon, and I put a exclamation mark. Then you can see this is the hash value it is generated, which is there in the slide, right? But if I remove the exclamation mark, you can see uh, before deleting this exclamation mark, you can notice here the SHA value is 7E4A. If I remove it, it is changed to 6978. Moreover, if this capital T is, suppose I write small t, again the hash value is changed to 8426 and followed by the rest of the hex digit. So with a minor change in the input text, even if there is a space, you will get a different hash value as your output. This is a simple, you can say, example, and irrespective of the tool also, you will get the same hash value. For example, the world is a balloon. This is the hash value. There is another site which you can visit, that is, I'll post in the chat box. It's also a very nice tool. You can visit this one, where you can get the blockchain demo. Suppose I pasted the same data here. The world is a balloon, right? Then you can see you are getting 8426. Here also you are getting 8426. Because both uses the same method, that is SHA 256. So you put any data, you can get the corresponding hash value. Like we have seen that in the previous case, when it reaches to the receipt, it is received by the receiver. The receiver can generate hash in multiple ways, and she can compare that both hash values are same or not. If same, then the transaction file is verified. Otherwise, there is some modification happens while it is while it is in transit, right, or in between the two different party. Okay, there is another important component that we will discuss here. So you can visit this website to get this one. There is another important component in the blockchain that is called as mining. So mining is the mechanism where the nodes, which we call as miners in the Bitcoin world, or we call as a forgers in the Ethereum, they would validate new transactions and add them into the ledger. Like you consider this is the blockchain network, you can see there are set of blocks are there. Each and every block is having version number, then previous block has, right? If it is the first block, you will not get previous block has, but rest of the blocks you will get the previous block has. Then it contain Merkle root, which is nothing but the hash of all the hashes of all transactions in the block. We have timestamp, we have difficulty, like if you go for higher, very long message, right? And if you there are number of transactions are more, then difficulty is low. When number of transaction is less, difficulty level should be high. And nonce, as I mentioned, it is a random number. These are nothing but the details related to the block. And this is the block we have proposed here, which we want to add in the blockchain. So what happened? This block header information, like I mentioned, that lightweight nodes are taking care. They are looking into the block header only. They don't have any capability to see each and every details, the whole transaction history. So by combining them and applying the hashing technique, you can generate a hash. And if this particular hash value is less than the target value, yet the target value is set based upon the mining difficulty. If it is no, then you can increment the nonce and again generate the nonce and combine and hash and generate the hash value. But if the hash value is less than the target value, then you can say the puzzle is solved, and those miners or the first miner who approved it, that particular node is going to be rewarded, and at the same time the block is added to the blockchain. But if this particular condition is not satisfied, if the hash is not less than the target value, then you have to increment the nonce. It is not going to be added into the blockchain. Again, this is purely based upon the consensus mechanism. So when I'll tell you about PEX OS consensus mechanism, which is the first consensus mechanism in the distributed peer-to-peer network, there you will see what is the importance of this target value. Now you can visit this particular site, which I have said in the chat box only, to explore more about this particular demo. So this is only simply we put a data and we got the hash value. And if you want to know about the block, you can go to this particular tab. Let me share also. If you have not received it, you can download. You can click here in the chat box. So here you can see a simple block. A block has a block number. It is having a nonce and it is having a data block. And using this, a hash is generated. Generally, the first block is having, you can see this is the first block in the blockchain. That's why the hash value starts with 0. Normally, it is having 4 zeros. Like here, you can see 0, 0, 0, 0, then F7, right? So you will find 4 zeros in the network. For example, I want to write here my name. So it shows that I have modified something. That's why you can see the color is changed here, right? Then nonce value is 72608. When you click mine, so it will update you the hash value and accept this particular block. So mine help you to validate a particular block, whether to accept that thing or reject thing, that depends upon this mine, right? This mine button, right? And if you change something, again the hash value is changed and this block is not validated. And in order to validate that, again you have to click mine, right? Once mining is done, again this one is validated. So you can see its hash value is 4 zeros, right? It has started with the 4 zeros. Now come to another important component that we called as uh, consensus protocol, right? Consensus means you can say the nodes in the network can achieve agreement on the data value. Okay, just like it is a mutual agreement of all the nodes that are associated with the blockchain. Like we have discussed till now about, we have seen the word that is called as a proof of work, which we call as POW. We have also seen that is called as a proof of stake, that is called as POS. So POW is an algorithm that is used in the Bitcoin, and POS is the algorithm that is used in the Ethereum, right? They are different. These two consensus mechanism is different, right? How to make a consensus? Like in a particular class, if there are 50 students are there, you want to make a consensus in a particular agreement. Like you want to change a particular time slot, right? Your class is scheduled from 9 to 10. You want to change it from 2 to 3. So you need consensus in that case, right? So for consensus, you have to apply some algorithm, right? So the algorithm may be proof of work, it may be proof of stake. So we'll see much detail about this one while we are going to discuss the consensus protocol or algorithm. Now you can see in this one, like we have seen, there is only one block in that demo. So the first block is called as the genesis block. How the first block is different from other block? Because in the first block case, you don't have the previous block has, right? But other blocks you have the previous block has, but only the first block case is there is no predecessor, you can say, just like a root of a particular tree. So we consider that as the genesis block without any previous block has, right? And what actually this block contains? The block contains the transaction details. Like here you can see, if you look into block 1 has, it contains the previous block has. And if I change something here, right, it is going to affect the current block and subsequent block. Suppose there is a transaction, there are set of transactions there in the block 1 has, and if you are going to modify these transactions, then that is going to affect block 1, block 2, block 3, and so on. It is not going to affect the block 0 has or genesis block. If I modify something here in block 3, it is going to affect block 3, block 4, and so on. It is not going to affect block 1, block 2, or genesis block. And also the block contain the timestamp, because timestamp is very much required in order to avoid a one concept in blockchain that is called as double spending. We are going to discuss that in next. So in order to avoid that, the timestamp plays a very important role. So whenever one person has make a transaction, if any fraud happens to fraud initiated by another transaction, that can be easily identified through this timestamp. We have nonce and we have Merkle root, which contain the hash of previous hash values, right? Hash of all the hashes of all the transactions in the block. Similarly, all the blocks are having these informations. Okay, they have a link to the previous block. So here you have a hash value. The same value is available in the next block's hash. That block is having different hash, but previous block hash you have the same thing. So if you modify something, that is going to impact the others. So we can easily notice that particular thing. Now let us see different blocks which we have seen here. You can go to this blockchain demo site. If you click this tab, that is blockchain. So I will paste this in the chat box. You can go through this link. Here you can see there are set of blocks are there, right? You can see this is your block 1, this is your block 2, block 3, block 4, and block 5. So there are total 5 blocks are there. And you can see the nonce. The nonce values are different in each and every block. Although it is generated randomly, but it is unique in each and every block. And you can write some data here. Now all are in green because you can see the previous hash of the block 1 is not there, right? It is a genesis block. That's why it is filled with all zeros. All zero indicates there is no predecessor of block 1. But you can see there is a hash value here. The same hash value is available in the block 2, which we call as a previous hash value. But this block is having its own hash, which is same as block 3 hash. So you can see first case it is 401578. Here also it is 401578. Similarly, block 2 case it is 4012. Here also it is 4012. Similarly, here the current hash value is 40B9. You will get 40B9 here. 40A, then 40A you will get in that particular block 5. And it is having its own hash. And it is the last one. If you want to add any other block, then you will see you have to take this particular hash value, which is nothing but the previous hash value of block 6. Now you can type something in this data. For example, I am writing my name here. So I am modifying a particular block. As I said, as I modified the block 1, it is not only affecting block 1, but also it affects block 2, block 3, block 4, and block 5. Right? Now suppose I will remove it again, it will be green. Suppose I am modifying this particular block, then you can see it is not impacting the genesis block, right? And if I modify again this particular block, you can see 3, 4, 5 is affected, but 1, 2 is not affected. So that's why if any modification happens in the blockchain, it is going to affect the current block and the subsequent blocks. Okay, now you can see there is a nonce here. Some data you can paste here. Suppose I am writing my name, my middle name here. Okay, and my surname here, and my institute name, and I want to write my institute location, right? So once you have modified something, you have to mine it. Then only it will be considered as a agreed block, right? Now you have modified one out of 5 block, only one block you have modified. So that is also not going to be accepted. You have to also modify this one. That's why I told you one attack that is called as 51% attack. If you want to modify, at least 51% of the members need to agree with that one, which actually really not happen, right? That's why this is satisfying the property of immutable. It is not possible to modify. Similarly, you can mine this one, then you can see the hash value is changed. Now also you can notice here the hash value is this one. When you click mine, again the hash value is changed, and now all blocks are validated, right? So as much as you want, you can add, right? Because the hash value is fixed. You write a one word or you write 100 transactions. Actually, the data contain the transactions only, right? It contains the transaction only. So irrespective of the transactions, you will get the same fixed size of the hash value. Okay, because this hash value is used for only for verification purpose. Right, transaction file is signed by digital signature, but these transaction details, okay, it is signed by the digital signature of the receiver. But what receiver actually doing? Receiver is actually comparing these two as. That's why this is fixed, right? Okay, so in this way, actually, the blockchain works. There is another site that you can visit that is called as blockchain demo.io. It's also a very nice website. Let me paste in the chat box. You can visit this website that is blockchain demo 2.0, and the link is blockchain.io. So here you will get the details about the concept of blockchain in detail. Like here it is mentioned, a blockchain is a distributed database secured by cryptography. It is the technology behind the cryptocurrency, that is Bitcoin. And this demo will guide you through the blockchain step-by-step process. The demo is also covered in this Medium article for pre-code camp. Okay, so you can see there are 28 slides are there. So you can move up to 14 slides. So you can see whatever concept we have discussed till now, these concepts are there in all the 14 slides. Let me show you these first 14 slides. So what is new in this particular version? They mentioned that you can see you can build a P2P network. Like here, if you notice, there is only one peer here that is called as Satoshi, right? You can add here. You can see add peer button is there. If you want to add more peer, that also you can add to this particular networks. And some more explanation you can get 2.0 in comparison to 1.0. And source code also in each and every step. If you want to see the source code in Python, you can also get this one. Okay, the first one is called as the blockchain has a list of blocks. This is an example of a simple block, which I mentioned to you. That block name is called as Genesis block. So you have some data here, like it is written welcome to blockchain demo 2.0. If I delete a particular thing, then hash is changed. As it is a Genesis block, the previous hash is equal to 0. And if you want to get the, you can click here to get the nonce value. The nonce value is 13441. Suppose I'll remove this one. Then again I want to get the nonce, I'll get a different nonce value. Now coming to the fourth one, each block store the following information. We already seen it contain the index, it contain the timestamp. This is your timestamp, right? You can see it is written Monday, 6th February 2023. Time is 6:10:08 as per GMT, Greenwich Mean Time, right? It's not as per Indian Standard Time. It contain hash, it contain the previous hash value, it contain the data, and it contains the nonce. So if you want the code, you can simply click here, show code. So you will see, I'll paste this code here. So this is a simple code. Okay, that you can use while you want to write a simple code in any programming language, right? Here we have declared a class called block, and through that class, they have mentioned about the index, previous hash, timestamp, data, hash, and nodes, right? Okay, the next one is, as I mentioned, the index in the position of the block in the chain, and Genesis block, the index is 0. Okay, and the next block is having index 1. Now this is the timestamp, as I already mentioned. And now come to hash. The hash looks like a bunch of random number. In fact, it is 64 alphanumeric digit, and it contains the alphanumeric letters, numbers or letters. Okay, so this is the alphanumeric value that uniquely identify the data or the digital fingerprint of the data. For example, if you see the properties of hash, it is of fixed length that we know. Same data always mapped to the same hash. I already shown you. If you write OK in this tool, or you write OK here, you will get the same hash value. Right? You will get the same hash value. You will not get different one. Okay. So different data, if the data is slightly changed, even if you paid a simple space, then the hash value is going to be changed. And it is very easy to compute, and is infeasible to convert the hash to the data. If I give you the hash value, I will ask you get the data. It is difficult to get because it is a one-way function. And a small change in the data leads to large change in the hash. Like we have seen, if I am modifying something in the first block, it is impacting all other blocks, including the current block, right? That's why it is not possible to easily modify. Now, what do you mean by valid hash? A valid hash for a blockchain is a hash that meets a certain requirement. So for this blockchain, having 3 zeros at the beginning, here you can see 3 0. In some cases, we have also seen there are 4 zeros. So 3 zeros at the beginning of the hash is the requirement for a valid hash. How to know a hash is valid or not? First, you will check that it should contain the leading values are zeros. So number of leading zeros required is the difficulty. Okay, it also shows the difficulty, whether the difficulty level is high or low. Like I mentioned, if there are many transactions are there, many nodes are there, then there is a low difficulty. But if there are less number of nodes are there, then it is having high difficulty. Okay, how to calculate this hash calculation? So if you put f of data, then you will get the hash value, right? This is a one-way function. Like f of data is equal to hash. If you take f from this side, okay, so it is called as f inverse, right? So f inverse of hash is equal to data, which is not true. That's why it is called as a one-way function. So since this hash is a digital fingerprint of the entire block, the data is combination of your index, timestamp, previous block, block data, and nonce. So you can say f of index plus previous hash plus timestamp plus data plus nonce is equal to hash. There is a simple representation, that is f of data is equal to hash, but f of data means everything, right? It contains previous one, it contains the nonce and everything. That will give you the hash. So for example, you can see index of the Genesis block is 0, right? Previous hash value for Genesis block is 0. Suppose timestamp, we have mentioned some. So like you can say this today is 6th February. You can write 06022023. Then say now the time is 11:45. I am writing 1145. Then this is your data, that is welcome to blockchain 2.0. and nonce we got is CH04. Okay, every time you may get a different nonce, right? It is randomly generated. So that will give you a 64 bit hash value. And this is the previous hash is 0 because it is the genesis block. And this is the message you can write here if any message you want to write. This is the nonce value, right? Nonce is the number used to find a valid hash, right? Every time the nonce value is changed, if the nonce value is changed and it is a part of your function, then definitely your hash value is also going to be changed. Now you can see the mining of a block, right? You can see here the nonce value is changed, right? Previously I told you index, previous hash, timestamp, data, and nonce. Put together, we are generating the hash value, right? But you can see the nonce value we are changing here. If you change the nonce value, then hash is changed. Okay. And we are matching whether we are getting the correct value or not. Like here you can see it is checking with all the nonce value. We start with the nonce value 0 and keep incrementing by 1 until we find a valid hash. Like I told you while we are discussing uh, what that is, I told you that comparison, right? When you compare whether it is a correct one or not, right? In that case, that the mining process we are checking is hash is less than the target value or not. If it is not target value, we simply increment. Like here you can see we start with a nonce 0, we increment by 1, and when you get a perfect nonce, then you will see the same code, then you can say it is valid hash is found. Nonce 604 produced at a valid hash value, right? So the difficulty is increases when the number of possible valid hashes decreases. Okay. And with fewer possible valid hashes, it takes more processing power to find a valid hash. And if the hash on the block is invalid, click on the tool button to mine the genesis block. Now this is your data mutation. Okay, if you want to change something, like I have changed instead of demo 2.0, I have written only up to demo, then you can say the hash value is changed. Okay. So suppose I want to add blocks. You can go to this one. You can add also blocks. Like you can see there is a add new block button. I want to write, let's say, welcome to blockchain demo. Here I want to write welcome to NIT Warangal. Okay, this is my data. If I add the new block, you can see previous hash value here is 0, but here previous hash value is same as this particular value, right? And it is validated with the nonce 5533. So if I modify something here, then it is shown in the red color, which says that you have not properly, you have changed the data. So for accepting this one, suppose I want to take welcome to blockchain, again you have to validate this one, again you have to validate this one. So for a smaller blockchain, it is more prone to attack, right? But if you go for a larger blockchain, 51% people will not agree for this particular modification. So if any modification happens, it is easily captured by in the blockchain process. Okay, so let us proceed to another example. We have another 10 minutes. I'll show you this example. Rest things I will cover in my next lecture. Okay, this is a very simple example. Imagine there are 4 friends are there, Jack, Ted, Sam, and Phil. So they decided to go for a dinner, right, to a particular restaurant, right? So they decided that today dinner will do in a particular restaurant. So all this they mentioned a particular time and a restaurant or a location, and they reached to that particular location. After they are done, Jake initiates the to Jake actually pay the particular bill. So he initiates for the payment, right? So the total amount they paid by Jake on behalf of 4 friends, that is Jake, Ted, and Sam and Phil. And later point of time, they have decided to split these expenses among the each other. Like if you go for a Paytm app, when you pay in some store, you can see there is a something it is coming that is called a splitting, right? You can split that amount with your friend. Once you click this split, it will ask which friend you want to share this information, right? So your friend will also get the same bit that this much amount is paid by your friend. So you can decide that how much you can pay to your friend, right? So they decided to split these expenses among each other. Then what happened? Phil sent the amount to Jack. So in the next day, when this Phil sent, this person has sent to Jack via online money transfer, the transaction goes through without a hitch. So suppose early morning you are doing a transaction or late evening you are doing a transaction, number of transactions are very less, so there is a high probability of success, right? So Phil has successfully transferred the amount which is decided to the Jack. But when same transfer or trade transfer to Jack, unfortunately the transaction is failed, right? So the transaction is failed maybe due to busy network. So there are various ways you can see why the transaction is failed. Minimum maximum time we can see the bank network is not available, or there may be some technical issues also, or you may reach the transfer limit. A number of transactions are also limited, or how much amount you can transfer, that is also limited. Or you can say, let's say account is hacked by someone, or it may be high transfer charge. Okay, sometimes that much amount is not available in your account. Let's say for that also it is failed. So in order to solve this one, what they can do, they can use the cryptocurrency, right? Let us see how they are going to use the cryptocurrency. Okay, I'll go back to that example directly. So let us see this same problem, how to solve it. So let us, they have used the blockchain network to do it. So first what they did, first when the first person Phil sends 2 Bitcoin to Jack, they decided that 2 Bitcoin we have to transfer. So you can see in blockchain there is a transaction initiated, that is Phil has to transfer 2 BTC. BTC stands for the Bitcoins to Jack, right? So the transaction details between them is permanently inscribed in this particular block. And assume that, for example, I have not shown this particular slide. So you can see, assume that before making any transaction, as they decided to split the amount, suppose Phil is having 3 Bitcoin, Ted is having 3 Bitcoin, Sam is having 3 Bitcoin, and Jack is having 5 Bitcoin, right? So all of them are having 3 Bitcoin except the Jack. Jack is having more Bitcoin. So here the field transferred 2 Bitcoin to Jack. Initially, Jack is having how many Bitcoins? 5 Bitcoins. So when the transaction is successful, the field is having 5 plus 2, total 7 Bitcoin. Right? So now the transaction is successfully saved. So see here, once this field transferred 2 Bitcoin to Jack, Jack is earlier having 5, so increased by 2, so it is 7. And Phil is having earlier 3, so it is reduced to 1, right? Jack is having 5 earlier before making this transaction, is having 5 Bitcoin, and Phil is having, you can say, 2 more Bitcoin, right? Sorry, Phil is having 3 Bitcoin, and you can say Sam is also having 3 Bitcoin, and Ted is also having 3 Bitcoin. So when the first one is happens, right? Okay, when the first one is happened, Phil transferred 2 Bitcoin to Jack. So Jack Bitcoin is increased to 7, and Phil Bitcoin is reduced to 1. So you can see this is the updated one in the blockchain. Now what happened? Sam initiates, okay, Sam initiates 2 Bitcoin to Jack. So same 2 Bitcoin is deducted, so it is updated to 1, and 2 Bitcoin is added to Jack, so it is 9. Okay, next one is uh, next one. Okay, this is same. Now Ted wants to transfer, not this one. This one is done. Ted transfer this 2 Bitcoin to Jack. So Ted's Bitcoin is also reduced to 1, and this is reduced to 11. Now you can see this is the update what we are making in the ledger. But this ledger is not with only Jack. This ledger is there with everyone. So Phil can also see that whether Ted has paid or not, Sam has paid or not. Similarly, each of them, they can determine whether the other friends has paid the amount to Jack or not. That can be easily identified, right? But in later point of time, suppose Phil wants to again transfer some amount, let's say for different cause, 2 Bitcoin to Jack. But the number of Bitcoins the Phil has here it is 1. But he wants to transfer 2. So this transaction is denied. Okay. So as we are maintaining the public ledger, what we can say, a hacker will not be able to alter the data in the blockchain because each and every person have a copy of this particular ledger. If something is modified in the ledger, it is required consensus of each and every node or each and every uh, participant, right? Each and every person, so which is practically not possible. And the data within the blocks are encrypted by a very complex algorithm using cryptographic hash function. So it is difficult for anyone to identify. It is difficult for anyone to modify that one, right? Identification becomes very easy in this particular process. Okay, so the last part just I want to discuss before concluding. The same thing I have written here. Suppose Joy want to transfer zero point 0.5 BTC to the N. So Joy requests the proposed transaction, which sends 0.5 BTC from his wallet app. This is the wallet of Joy, and from the wallet he wants to withdraw 0.5 BTC transfer to N. Then step 2 is the proposed transaction is broadcast to the network. So as he initiates a particular transaction, the transaction is broadcast to all the network. Everyone can see that particular transaction. Now, miners verify the transaction and bundle it into a block along with other transactions. The miner is now verifying. The first miner is going to be rewarded, right? But miners will check that whether this transaction they are going to verify or not, right? Okay, because with their verification only this transaction is going to be allowed. In the step 4, miners complete solve the complex mathematical puzzle, and in order to solve this puzzle, they are using their computational power, including electricity. So the miners are rewarded. So next one is the nodes verify the miners works. Once miners works is done, the nodes is going to verify the miners works, and once the verification is done, the block is added into the blockchain, right? One more block is added to the blockchain, and the updated copy, if there is any updated copy, once a block is added, you have a you can say updated ledger, right? That is circulated throughout the network, and this complete your transaction details, right, in the blockchain process. Okay, so we'll stop here. So if you have any questions, I'll ask. You can ask. I'll try to address it, and rest part I'll cover in the next session.